I'll discuss about the escape velocity of a satellite. So if you are considering that a satellite is revolving around a planet in a circular orbit of radius r, so let's say the mass of planet is nothing but capital letter M, and the mass of satellite we can take it as nothing but small letter m, and this satellite is revolving in a circular orbit of radius, let's say that is equal to r0, and this planet satellite is moving with a velocity, let's say that is equal to VO, where VO is known as nothing but its orbital velocity. Now in earlier we calculated the value of total energy, and we know that this total energy is going to be a negative value. Now if we are increasing the value of velocity, so let's say we are increasing the value of velocity of this object from V0 to a value V, so that it will be able to escape from the gravitational pull which is exerted by the planet. So over here again we will use the same concept for the calculation of its escape velocity, that is total energy should be greater than or equal to 0, and the value of total energy is the sum of its kinetic energy plus potential energy. So we can write now the kinetic energy of this planet becomes satellite becomes equal to half into m into v square, plus potential energy we know that it is minus of g into m divided by distance, which is r0. So this value should be greater than or equal to 0. So we can write this half into m into v square should be equal to g m divided by r0. So we can cancel this m and this m. So again this is not going to depends upon the velocity of satellite, the mass of satellite. So we can write the value of escape velocity is equal to 2 into g into m divided by r0 is a value of v square, or v is equal to under root of 2gm by r0. Now just remember that in case of escape velocity of an object from the surface of a planet, we wrote this equation same as like g into 2 into small letter g into r in terms of acceleration due to gravity. Here we cannot write in terms of acceleration due to gravity on the surface, because this r0 is not the radius of planet, it is the radius of orbit. So we need to keep it in this format. Now in some question they'll ask to find out what about the value of percentage increase in orbital velocity so that it is able to escape. So we know that initially the satellite was not at rest. Initially the satellite was orbiting with the velocity which is orbital velocity, and we already calculated the value of orbital velocity in the previous classes, that is root of gm divided by r0. So in question sometimes they'll ask to find out what about the value of percentage change in velocity so that the satellite is able to escape. So initially satellite was moving with the velocity of v0. Now the satellite is moving with the velocity, take it as VE, escape velocity. So we can find out the value of percentage change in velocity. Percentage change means nothing but the value of final velocity minus the value of initial velocity divided by initial velocity into 100 will get the value of percentage change. So we know that we can write the value of escape velocity in terms of orbital velocity also, because escape velocity is root of 2gm by r0 and escape velocity is root of gm by r0. So we can write this escape velocity is root 2 times of orbital velocity. So instead of escape velocity we can write is root 2 times of orbital velocity minus orbital velocity divided by orbital velocity into 100. So we can take this orbital velocity as common, so it is going to be root 2 minus 1 divided by orbital velocity into 100. So this orbital velocity and this orbital velocity get cancelled. So we can write the percentage change in velocity is, we know that the value of root 2 is 1.414 minus 1 into 100. 1.414 minus 1 is 0.414 into 100. 0.414 into 100 is nothing but 41.4. So we can write we need to increase the velocity by 41.4%. So or we need to change the orbital velocity or increase orbital velocity by 41.4% so that the satellite will be able to escape.